So today is your experimental day now, and it's the same experiment, that is experiment number 1, but we are going to start with step number 2. Before the vacations, we were on step number 1. We have completed step number 1. Now we are on step number 2. And what is step number 2? It is detection of elements. Now you know that this is your organic compound, right? This is your organic compound. It has, you can see the shiny crystals. It's shiny. You see acetanilide, it's shiny, right? I will also give you, I will make you learn how to do the recrystallization of acetanilide. I hope you have done in your part 2. I don't know you have done or not, but it is in your course. Anyway, so this is acetanilide. Now in its physical state, we all know because you have gone through the first step and you know that what color it has. It's shiny powder-like, very tiny crystals, right? And they are a little bit, they are now a little bit clumsy or granular because they are absorbing moisture. Otherwise, it's shiny, pure, solid. Anyway, so this organic compound, it's an organic compound. Its name is acetanilide. We know it. We know its name. It's a known organic compound. So now we know everything about its physical aspects. What physical aspects it has got? It has the name acetanilide. It has a molecular formula. It has the structural formula. Very well. You know the color. Its state. What state it is in. What pH it has got. Right. In which solvents it is soluble in, as we have done the solubility tests also. I'm just revising the things which we have done because it's very important to go through the things which you have done and now what you are going to do now. So it's just the continuation of your first step. So this organic compound, all the organic compounds are loaded with carbon and hydrogens. We know that they are loaded with carbon and hydrogen. But besides carbon and hydrogens, there are other elements also present in them, like nitrogen, like sulfur, like halogens. So, but these elements are not bonded through ionic bonds. They are bonded covalently. So they are not detectable. We need to detect them when we convert them into their ionic forms. And for that, we are going to make this Lassaign filtrate. Because why? You will get this. You will extract. You will go through the process of extraction, and you will extract these elements there. And when you prepare the sodium extract, we call it sodium extract, and we call it Lassaign filtrate. Lassaign was the name of the scientist who discovered this method of preparation of Lassaign filtrate. That's why we call it, when we have a filtrate in the end, we call it Lassaign filtrate with his name. Somebody can ask you, what is Lassaign? What is this Lassaign? So you should know that it is the name of that scientist. We also call it sodium extract. Because why? We also call it fusion test. There are 3 names. Fusion test also. Fusion means you are going to fuse your organic compound with sodium metal. You are going to fuse this organic compound with what? With sodium metal. Now what is fusion? Fusion means you are going to react this organic compound with sodium, right? And you are going to get sodium cyanide, NaCN, right? Sodium Na plus carbon plus of course the cyanide ion, and you will get NaCN in the first step. So this is how the reaction is gonna take place when you are preparing the sodium extract, because these are all elements are bonded covalently. They were non-detectable. So we are converting them back to their ionic forms so that we can detect them. And how we will detect them? We will detect them when we will first prepare sodium extract, and then we will go through 3 tests, that is test for nitrogen, test for sulfur, and test for halogens. By reacting for test for nitrogen, when you're going to detect that whether your compound contains nitrogen or not, though you know it that it has nitrogen in it, but you need to confirm it. Why? Doing it practically, right? By going through the experimental process. This is called experimental chemistry. Chemistry is nothing without experiments. It's full of experiments, right? The theory is directly related with experiments. So the theory and experiments, they go side by side, right? So it's just like that. For detecting nitrogen, you have to react it with ferrous sulfate. For detecting sulfur, you have to react it with sodium nitroprusside. And with the continuation of other 3 tests. Now let's start how to prepare. You can just give me one register, rough register, और अपना journal दे दें, no problem, ये भी ठीक है. कोई पेज ही नहीं है कि इसमें? I need a proper register, दो ये नहीं दो. because you need to know how to start the experimental process, how to write down on the journal, so or on your logbooks. Acha, in the labs we call a book called where we put where we input our data. We call it logbook, right? There are certain names. We call it logbook, in which you are going to put your data. Whatever you are getting the results, we call it data. You are collecting the data. This is all the data you are collecting. So we call it a logbook or a journal. It is never called a register. It's not a register. This is a register, a thin one. This is a register. So try to differentiate between the stationery, what is a book, what is a register, what is a logbook, and what is a journal. Journal has got, or logbook has got, a number of graph papers also in it, right? When you read physics or any other mathematics, you know that it has got the graph papers also in it, right? And we plot graphs. उनको देखना ज़रूरी है कि वो आए हैं अभी तो आप उनको ज़रूर पीछे मुड़ मुड़ के देखेंगे. Is it necessary? You should pay attention to me, towards me, instead of watching the people who are coming inside the lab, huh? You do not need to. Ghum ke you are watching them. I don't know why. Okay, so this is experiment number 1. Very good. Step number 2. And you will write down detection of elements. Please adopt this format. Whatever I'm writing here, please adopt this. I'm requesting you, do not adopt your own ways and means to form the journal. No need to, because they have already given us a way to do or to continue with our experimental process, right? So just follow this experimental process. I would appreciate that, right? So detection of elements. Now the first step towards that is preparation of sodium extract, or Lassaign's filtrate. Now the extract you are going to get in the end is called filterate. Filterate, filterate, right? One can ask you what is a filtrate. One can ask you what is extract. You should know these terms. These are very basic level terms of chemistry. You people are now chemists. You are not only the students. You are students of chemistry. You are wearing these aprons. That means you are chemists.
After filtration, the product will come filtrate.
Of course. Not after filtration. Of course, you will go through the process of filtration, but after the whole process, we do filtration also. So that's why you got an extract. And that extract, they have termed it as a filtrate. So that's why I'm saying the same thing, it's a filtrate. And of course, whenever they will say filtrate, that means आपके दिमाग में फौरन this thing will come into mind that it does went through the process of filtration. That's why it's called filtrate. Fine? So now, for once in the journal, you are going to write down the procedure. You will write down this whole procedure. No, you will not make any heading. You will just make this heading, preparation of sodium extract, and you will copy down this method which is written over here. Now, I would appreciate if you will somebody read now. Start reading. Who is good in reading? Yes, who is good in reading? Start reading the procedure.
Dry small piece of sodium metal between the folds of the filter paper. Introduce this dry aid the organic compound in such way that it covers the sodium pieces.
Now, wait. This is your ignition tube. Everybody knows it's an ignition tube. Why we call it an ignition tube?
Just because they ignite in it?
We will ignite in it. Or now I would appreciate if I ask from the person who will answer only. Do we reuse these ignition tubes? You tell me. Are these reusable? Next.
We can't use the ignition tube in the same process.
And in another process you can use it. That means
After using the machine.
you can rinse it and you can wash it. You in the back.
Yes. After washing, you clean.
You.
Yes, ma'am, we can use it.
Next, girls. No, ma'am. What?
You cannot use.
You cannot reuse.
You can't use it again.
Can we wash it?
No, because it is disposable, right? So we throw it in the dustbin.
It's disposable.
Yes.
It's not reusable.
Yes.
Keep this thing in your mind. This is an ignition tube. It's not a test tube.
Yes, ma'am.
Test tube is a bit bigger, larger in size. This is very small. It's ignition tube. Ignition means ignite. Ignite. That means jala dena, to burn. That means if you burn something, that means you're not going to get the residue of that. Huh? You will use the residue in making the extract, and then it's over.
Yes.
It's never washable. Boys, you were all almost wrong. You were right, but these four were all wrong. And so sure. So sure, so wrong. Wow. So, this can't be reused. This can't be reused. This can't be washed. You cannot rinse it. You cannot wash it. Keep this thing in your mind forever. Ignition tube and the capillary tubes both are discardable. They are not reusable. Once you record your experimental setup, whatever setup you are using it in, you will discard it afterwards. Are you getting me?
Yes, ma'am.
These four boys. जिन्होंने पढ़े उससे बोला ठस्से के साथ.
If we reuse it, again, what will disadvantage? Our result will be affected by the reuse.
It's not you. It is not made for reusing it, because it is used in our experimental process. It is only used for igniting and for making this this fusion test. For the fusion test, it is made so that you are going to fuse your sodium metal, dry sodium metal, with your organic compound, and then you are going to go through the process of heating. So you will not use it. Fine. So now, if you jump to your preparation, now they are saying dry a small piece of sodium metal between the folds of the filter paper. Now you have a sodium metal that is lying inside. Now, Mr. Irfan, our lab assistant, is going to give you. It should be the size of a pea. Matar ke dane jitna. It should be a size of a pea, not more than that, because usse bhi chota. Because just look at the size of this. You have to introduce that sodium metal inside this. So it has to be very small in size, right? And make sure your ignition tube, before inserting that, it's clean. It's not having any water vapors inside it, because sodium, it reacts. It's a metal. It is an explosive. It gets exploded when it gets in touch with any water molecule. You are not going to touch a sodium metal with your hands. You will use spatula. Otherwise, your hands will burn, right? So you will, now he's saying, first thing is that dry the sodium metal between the folds of the filter paper. That means you are going to cut the sodium metal. You'll put it here and you will dry it on the filter paper. Though he has already dried it, but you also make sure that this is what they are saying. Fold between the filter paper and, why? Because the sodium metal is inside. It's lying in a beaker or in some china dish, porcelain dish, and it is immersed inside kerosene oil. Why it is in kerosene oil? Because it's hygroscopic. It reacts with air. It reacts with water, moisture, and there's a lot of moisture in the air, so it gets reacted with that. So that's why we keep it in kerosene oil. And for that reason, they are saying dry. Every word they write has got some meaning. That means dry.
Then we can wash the ignite before the inserting the sodium.
What you are going to wash it? The washing पे इतना ध्यान क्यों है आपका भाई? But शौक है. ये आपको clean मिल रही हैं. They are ready to use. These ignition tubes are always ready to use. They are never given to you, handed over to the students not in a way that they have to wash it. It's not a test tube that you're going to wash it. No. Never put water inside it until or unless your instructor asks you to do it. Your teacher, your instructor, your lab instructor. Lab instructor is the person. I'm your lab instructor right now. I'm explaining you. I'm giving you instructions about the things, the precautions and everything. Right? And the reactions, how you are going to proceed with the reaction. I'm explaining you each and everything. So this is also part of that do not wash it. It is ready to use. Right? And after igniting it, going through the process of ignition, it is going to be over. You will read the procedure and then you'll see how it's going to be finished. So how it will end up. Introduce the dry sodium metal. Yes, now read.
Heat gently the lower end of the ignition tube till sodium metals and react with the substance.
Okay. Wait. Now you will add your sodium metal in it. With a pair of tongs, you are going to hold it. Right? These my fingers are pair of tongs. Now you have added the sodium metal, just the size of a pea. Now you will take only this much amount of the compound, which just covers the sodium metal. That's it. It's like that. I'll show you how. It's like that. This is your ignition tube. This tube, I'm making it larger. This is your sodium metal. This is how much compound you are going to fill. That's it. This is what they said in the beginning, the first step. Only this much amount you will fill.
And like we just have to cover the sodium.
Only you
right?
have to cover the sodium metal. This is the first step. Then they said that heat the lower end of the ignition tube. This is your flame and this is your ignition tube. Lower end, this is the lower end, this is the upper end. Lower end of the ignition tube till the sodium melts and start reacting with your organic compound. So that means you are not going to keep it on the flame like this, consistency with constantly. No, you will put it over the flame and you will remove it. You will put it over the flame for a while. Flame should be blue. It shouldn't be yellow. Please make sure, because otherwise there will be a lot of carbon on your ignition tube and you will not be able to detect it. So now what happens that the sodium melts and it transforms into another form. Like you can see, it will present itself like a mercuric bulb for a while, and that state of sodium is called molten sodium. When it shines like a mercuric bulb, right, like mercury. So at that stage, yes. Now read this line.
Now add a little more organic compound
Now,
in the molten sodium.
okay. Now add again. You will take few granules of again compound and you are going to pour over that molten sodium, right? Yes, proceed.
And heat strongly till the bottom of ignition tube becomes red hot.
Okay. Now you will again, you're holding it with a pair of tongs. This is your flame. You will heat. You will now start giving it a strong heating. Now a strong heating will be done. That is, this is it. This is strong heating. Now keep this thing in your mind that the direction of your ignition tube is supposed to be very straight. It is not supposed to be like this. It's not supposed to be like this. You should not hold it like this. You should not hold it like this. Why? Because sometimes there is unreacted sodium that is left inside your ignition tube, and when you start reacting it and you give it a strong heating, it just bumps out. And when it bumps out, it can hurt somebody who is standing at the right side of your or of your left side, or somebody who's standing in front of you. So we always keep the direction of sodium metal, we hold it like that it should be facing upward. So if God forbid that if it bumps out, it will go up, fine, because it's quite it can hurt you, right? It can burn you when it bumps out, when it is unreacted. That's why in the first process, in the first step, we tried to heat it we took it to that much point where the compound, few of the granules of your compound, they reacted with the sodium metal, and the sodium metal got molten. It melted, and the reaction was started, right? Then again we added few more granules of your organic compound, and the first time we did not the strong heating, little heating was done, but now we will proceed with strong heating. And what is strong heating? That you are not going to remove it from the flame. Sometimes what happens that when you do this, in the first step of the heating process, your sodium metal was not properly heated. It never reacted. Some part was left, so it will catch fire. So when it catches fire, you will remove it from the flame and you will blow it. Try to blow it, okay? And then again you will keep it over the flame and react it. Now the strong heating will go on. Keep this thing in your mind again. Now see, this is your flame. If, for example, if this is your flame, it should cover the ignition tube till this end. You are holding from here. It should cover or heat your ignition tube till this much. This much of the ignition tube has to be burned strongly over the flame. This is the flame. Just see, the flame is burning it till the place you are holding it, right? Meanwhile, you will keep, okay, now read.
Plunge it while hot. In china dish containing 20 ml of distilled water, concentrate the sodium
No,
solution on
must. Now you have an ignition, china dish that has got 20 ml of distilled water at one side. As you will be working in a group, so you will be having that also, right? One of the group members can arrange these things. Your table should be arranged like that, the way I've arranged it. So your china dish would be containing 20 ml of distilled water. Now 20 ml, because we are not going to make an aqueous solution, that's why we use water, right? And we use distilled water. 20 ml you will keep it at one side, and when after the strong heating, you will see that the lower end of your ignition tube, it got reddish in color. That means not that it's gonna shine like a bulb, red bulb. No, it wouldn't be like that. But you will see that it's red hot. Sometimes you have seen your utensils when you keep it on the fire, over fire, they gets red in color, right? So this is, they've got a tinge, a reddish tinge over them. So why? It's because of the strong heating. The same way you will see a tinge at that moment. You're going to drop your ignition tube inside that 20 ml china dish containing water, like that, right?
Can you hold it with your hand?
No, beta, you cannot. Why you want to burn yourself? It's too much hot. It's red hot. This much is left. It's only for holding with the pair of tongs. You will use pair of tongs. You won't be using your hands for that. Your bare hands. No way. You will drop it inside the water, and then with the, if for example, if this is a glass rod, and if this is a china dish, what will you do? You will crush it. You will crush it slowly, like this. You will crush it into small pieces. You will crush it into small pieces of this ignition tube, the burnt ignition tube, with this containing sodium aluminum compound, right? Now what will happen? You will have the very small crystals of this burnt ignition tube inside it, right? You have an extract, some sort of an extract is there. Now what you are going to do? Read.
Concentrate the solution on the Bunsen.
Okay, now you have this 20 ml water. As it is 20 ml, you will measure it. You will put a measuring cylinder. If this is a measuring cylinder, put it over a flat surface. As I've told you, never hold measuring cylinder in your hand when you are measuring it. I don't want to see anybody doing like that. No, put the measuring cylinder over the plain surface, over a table, over your table desk, and then measure 20 ml of distilled water or any solvent you are using, whatever, XYZ. So now you have 20 ml of distilled water, and you have your this ignition tube extract inside it, right? You are going to concentrate it. Why we are concentrating it? Because it has got these elements, nitrogen, sulfur, and halogens. Maybe they are inside it. As we don't know, we are assuming that we don't know, though it's a known compound. We know it has got nitrogen in it, but we are assuming as if we don't know, then you have these elements present in it. And now what you are going to do, you are going to reduce the volume. You have 20 ml. In chemistry, if somebody asks you to reduce the volume, that means you're going to heat it. You're going to evaporate the solvent that has been used inside it. The solvent here we are using is distilled water. So we are going to evaporate some of the distilled water, right? So and how much you will be needing, because you have all these tests over here on the next page of your journal. You are going to make the 3 columns just like that here: experiment, observation, and inference or results. You are going to write down test number 1, test for nitrogen, that is the ferrous sulfate test, and then you are going to you will proceed. You will see how many tests are there. Number 1 test, number 2, number 3. There are a lot of tests. So that means you will be needing at least 11 ml of your distilled water. Oh, sorry, the sodium extract. You have the sodium extract. At least you need this much amount, that if you take 2 ml or 3 ml for each test, you should have at least 9 to 10 ml, right? So you will reduce the volume over the heat, over the Bunsen burner. You will put this china dish over the Bunsen burner, and you will reduce the volume till it becomes 11 ml. Now you cannot measure it because it's difficult to measure again. It's a qualitative analysis, so just analyze it, observe it, how much it was initially, 20 ml, and how much you have to reduce it. Okay. Just observe at that time. It should be at 10, 11 ml. That's it. Just the half of it should be left. Now, yes.
Bunsen flame over the wire gauze and filter. The filter is called a Lassaign solution or sodium extract containing elements as sodium salts.
So now you have sodium salts on the extract. You will filter it. Finally, you will filter it. You will get a filtrate or an extract that is in which the elements are converted into their ionic forms. Now they are detectable. You can detect them by going through the process, by going through the 3 different tests. That is test for nitrogen, sulfur, and halogens. The first test you're going to write here is test for nitrogen. For nitrogen, you are going to write down this test. You will use a test tube which is reusable, which is can be washed, which can be rinsed. Okay. Now we are talking about the test tube. So in the test tube, you're going to take 1 to 2 ml of sodium extract and then add ferrous sulfate solution. I've written here 3 drops of ferrous sulfate because the amount was not mentioned. So 3 drops are there of ferrous sulfate, and heat to boil. add concentrated sulfuric acid 2 drops. I've written 2 drops here. Sulfuric acid 2 drops, ferrous sulfate 3 drops. Now when you are adding these drops, in the first step you are going to add ferrous sulfate. So when you are adding 3 drops, add 1 drop and then shake it. Add the second drop, then again shake it. Then and observe if there is any change. Then again for the third drop you will again shake it. And then you are going to heat to boil. You will give it a boil, 1 boil only. And then you are going in that boiling solvent solution, you are going to add concentrated sulfuric acid, almost 2 to 3 drops you will add it.
Ma'am, how much we use sodium hydroxide to alkaline?
Alkaline, I have asked him to make it alkaline. You can use 10% sodium hydroxide. You can use, it should be freshly prepared. Alkali solutions are always freshly prepared. So make sure if he has made a proper fresh solution. So 10% solution is okay. Even 5% sodium hydroxide solution is okay. You can make 5% sodium hydroxide solution. I hope you know how to make percentage solutions. In physical chemistry, you learn how to make solution making. You should know how to make 5%, how to make 10%, how to make 1% solution. Everybody should know. So you will make that and you will add few drops of that alkali into yours. So your sodium extract would be alkaline in nature. Alkaline means its pH is, would be the pH range?
More than 7.
More than 7. Above 7. 7 is neutral. Okay, so now after going through the steps, you are going to observe your test tube that has got all that reaction products in it, that your color becomes Persian blue coloration, because you know it's acetanilide, it has got a nitrogen in it. It's a non-compound. So what it's going to give you a blue color. Now the blue color could be like this. Yesterday the group has done it, they got this color. It could be a bit lighter in shade, as for example the color of your journal, the blue color that they show me. It could be like this also, this bluish. It could be this bluish, lightish blue. It could be this bluish. It depends how much nitrogen content is there, right? And the way you have performed your experiment. Now keep one thing in your mind, that why I stress so much over explaining you this preparation of sodium extract, though it's only a 5 to 6 lines reaction. But why I stress so much over it? Because your sodium extract is supposed to be colorless. If it's not colorless, again repeat the procedure, make it again. Otherwise you are not going to get these results. That means you have done some contamination, you have done something wrong somewhere. Don't put your spatulas or your ignition tubes just as I have thrown over the table. Don't do it like that. Always keep them like this. I always keep this like this. Over some filter paper or over some paper. I told you in my first general lecture that bring a paper or something like that, so that your table is full of, they are full of chemicals. The table desks you are using are full of different chemicals, spilled chemicals, right? So you will go through the test for nitrogen. You have got nitrogen present in it. You have to make it present because you know your compound has got nitrogen in it. So this test is supposed to be positive. Then test for sulfur. Sodium nitroprusside test. Add 2 to 4 drops of freshly prepared solution of sodium nitroprusside to 1 ml extract. You will get a violet coloration. If you have got a violet coloration, that means it indicates the presence of sulfur. Now test number B is, if sulfur is there, then you are going to proceed with test number B, that is lead acetate test. It's a confirmatory test that sulfur is there. You will not perform test B if you does not have sulfur in your compound. And right now we know that our compound doesn't have any sulfur in it. So this test is supposed to be positive or negative. Test for sulfur. You tell me. Test for sulfur is supposed to be negative or positive? Positive. Why? You just speak without thinking. What is the name of our compound?
Nitrogen.
Our compound is...
Sodium intermediate.
What was the name of our organic compound we are using? This one. What is the name of this? It's a known organic compound. What is the name?
Sodium.
Next.
Sodium acetate. Sodium acetate.
Acetanilide. What are you doing? What you people are doing? Don't you know the name of your organic compound? Even you're using, you are doing the step number 2 of the same organic compound. You have done it in your step number 1. What was the name? Acetanilide. I'm repeating this thing again and again. It's a known organic compound. So what you are doing, you are not even concentrating. That means don't know the name of your organic compound up till now. This is very sad. It's acetanilide. So we know it has got a nitrogen in it. Besides carbon, hydrogen, there is a nitrogen in it. There is no sulfur. There are no halogens. So the test for nitrogen is supposed to be positive. The test for sulfur and halogen is supposed to be negative. Whereas nitrogen, the test for nitrogen should be positive, as we know the name. It's acetanilide. Do you know the girl? Yes, you tell me. What is the name of the compound? It has got nitrogen or not? It has a nitrogen. Does it have a sulfur in it? Does it contain the halogens? It has halogens in it? Better concentrate on your studies. You people are not concentrating. Please. This thing, it contains 100 marks. You are going to lose your marks. If you will work like, that you are even not acknowledging the name of your compound. A known organic compound was handed over to you. I wrote the name in my first lecture when I was introducing this compound to you. I wrote this, I made the structure, I wrote the molecular formula, I wrote everything there on the board. So that you should know at least the structure, molecular formula of your organic compound. So in the same sense, I was expecting that you know the name. And you are giving me this answer. नाइट्रोजन कैसे आपने बोला था? इसमें सिर्फ नाइट्रोजन है क्या? नाइट्रोजन घूमता फिर रहा है क्या खाली आके? 10 times 3. I hope अब भूलेगा नहीं. Okay, now I want to make sure one more thing, that please, whatever test you are getting positive, you have to write down its equation and its reaction on your journal at the left page of your journal. On the left page of your journal, you are going to write down the test you are getting the positive results with. You will write down the reaction. And reaction are given on the next page of your this. Just turn the page, you will see the reactions. Left side blank page.